Hello guys, this is Arvind here from MindMajix, and today I welcome you all to this amazing session on Snowflake tutorial. Okay, so let us quickly have a look at the agenda for today's session. Okay, so as you can see on the screen, we'll be starting with what exactly is Snowflake, and then we will discuss the features of Snowflake. Then we will have a brief introduction to the architecture of Snowflake, as in how does Snowflake work, what are the components that are present in the Snowflake architecture, and so on. Then we will conclude this session with a demo part. Okay, so in demo, we will have a hands-on experience on Snowflake. Okay, so I hope I'm clear with the agenda. Pretty simple. So before moving ahead, I want you guys to subscribe to MindMajix YouTube channel and also hit the bell icon so that you never miss an update from us. So without any further delay, let's get started. Okay, so the first point that we're going to discuss is what is Snowflake. Okay, so Snowflake is the first analytics database built with cloud and delivered as a data warehouse as a service. It can run on popular providers of cloud such as AWS, Azure, and Google Cloud platforms. There is no hardware present here, either virtual or physical, or software is also not needed to install, configure, and manage. And this Snowflake runs entirely on public cloud infrastructure. Snowflake is an ideal platform for data warehousing, data engineering, data lakes, data science, and developing data applications. Okay, but the main highlight feature of Snowflake is the architecture and its data sharing capabilities. In contrast with the traditional data warehouse solutions, Snowflake provides a data warehouse which is faster, easy to set up, and far more flexible. With its unique features, it soon became a leader in the data management solutions for analytics. So this was a brief introduction to Snowflake. And now let us discuss the features of Snowflake. The first and foremost feature of Snowflake is the effortless use. Snowflake is an overall simple and intuitive interface which allows you to load and process the data quickly. It solves issues using its exceptional multi-cluster architecture. We will have a look at the architecture part of this Snowflake in some time. The next feature here is performance and speed. Cloud's elastic nature enables you to load data faster or run high volumes of queries sometimes. You can scale up or scale down the virtual warehouse to take advantage of extra compute resources and pay for the only time that is used. The Snowflake platform ensures that the query is processed at an optimal rate with competitive deals. Okay, so the next feature here is availability of tools and seamless data sharing. Using a wide variety of tools like Tableau, Power BI, etc., can help you run queries against large data sets. And Snowflake's architecture allows seamless data sharing for any data customer. So the next point that we're going to discuss here is the cost effectiveness. The Snowflake interface cuts off the idle time and only considers the usage time. Both the computing and the storage cost has to be paid separately in this cost optimized platform. Through the compressing and the partitioning process, you can save a high amount of price. Okay. And the next point here is the elasticity and the flexibility. Snowflake offers higher flexibility, accessibility, elasticity, and value. The user can use both the warehouse and the query services in the same data lake. In terms of usage, the Snowflake is far more flexible as it can be used only when it is needed. Okay. And the next point here is the support of multiple data formats. Snowflake supports various data formats like XML, JSON, etc. It runs with any kind of structured, semi-structured, and unstructured data to address the common issues of handling incongruent data types which exist in a single data warehouse. Okay, and the last point here is the scalability. Snowflake supports instant data warehouse scaling for handling concurrency bottlenecks during high demand periods. It scales without the need to redistribute the data, which can be a significant disruption to the end users. Okay, so these were some of the features of Snowflake which makes it stand out from its competitors. Okay, so the next point that we're going to discuss is the Snowflake architecture. Snowflake's architecture is built for the cloud. Its unique multi-cluster shared data architecture delivers performance, concurrency, and elasticity that organizations require. It handles all the aspects of authentication, resource management, optimization, data protection, configuration, availability, and much more. Snowflake features compute, storage, and global service layers which are physically separated but logically integrated. Okay, so now let us try to understand how Snowflake differs from the traditional architectures. So shared disk architectures use multiple nodes for accessing shared data on a single storage system. And the shared nothing architectures store a part of the data in each node of the data warehouse. So Snowflake combines the benefits of both the platforms in an innovative and new design. Okay, so Snowflake processes the queries using the massively parallel processing compute clusters, where each node in the cluster stores part of the entire dataset locally. Okay, so as you can see on the screen, the Snowflake architecture has three components, basically the database storage, the query processing, and the cloud services. So if you talk about the database storage, so Snowflake stores all the data in the databases. A database is a logical grouping of objects consisting primarily of tables and views and classified into one or more schemas. We can store any kind of structured or semi-structured data in Snowflake, and all the tasks related to data are handled through SQL query operations. The underlying file system in Snowflake is managed by S3 in Snowflake's account, where the data is encrypted, compressed, and distributed to optimize the performance. The second component, which is the query processing component, this component processes the queries using the CS, where each virtual warehouse or cluster can obtain all the data in the storage layer, then run separately so that the warehouses do not share or compete for the compute resources. Virtual warehouses are actually used for the purpose of data loading or running queries, and they are also capable of doing both of these tasks simultaneously. A virtual warehouse can be scaled up or scaled down without any downtime or destruction. And the third component in this architecture is the cloud service. The services layer coordinates and handles all other services in Snowflake, including sessions, encryptions, SQL compilation, and much more. It eliminates the manual data warehousing and tuning requirement. Okay, so services in this cloud services layer include authentication, infrastructure management, metadata management, query passing and optimization, and access control. By design, all of these layers are independently scaled and are redundant. Okay, so if you're wondering how do these layers work together, so let us try to understand the life cycle of a query. Okay, so after connecting the Snowflake through one of the supported clients and starting the session, the first virtual warehouse submits a query and service layer verifies the authorized access in the database. And later it executes the operations defined in the query and then creates an optimized query plan. After this, the services layer sends the query execution instructions to the virtual warehouse, which allocates resources because any needed data from the storage layer can execute the query. The results of the query are then returned to the user. Okay, so this was the overview of the architecture, or how the Snowflake architecture functions in general using all these components: cloud services, query processing, and database storage. Okay, so let's just move on to the demo part, which is the next part of this session and the final part. Okay, so here I'll be showing you all of these steps, as you can see on the screen: the installation of Snowflake and downloading the data files. So data files are nothing but for diving deeper into the architecture of Snowflake, I have downloaded few data files which we will be using in this demo part. Okay, the next step, what you do is you log into Snowflake and create Snowflake objects, and then you stage the data files, and then you copy the data files into target tables, and then you can use various queries against the loaded data. Okay, once the queries are done, and once you like all of your tasks, or you can say the ETL operations are done, you can just wind up and clean up the objects that you had created in step 3. Okay, so these are the steps that we are going to follow, and now let me tell you how are we going to do this. Okay, so first what we have to do is we have to download the Snowflake. For that we have to go to snowflake.com. Okay, once you go to this website, and what you have to do is you have to first log in. Okay, here it says start for free. Okay, so you have to sign up, this 30-day trial, free trial on Snowflake. Okay, so guys, as you can see here, I have logged in into Snowflake. Okay, and here, if you click on help, okay, so let me just quickly introduce you to the interface of Snowflake. Okay, so here you can see the databases. Okay, the databases that are present currently. Okay, then you have shares, like how do you want to share your data in Snowflake. Then you also have data marketplace. Okay, so using data marketplace, you can discover new external data. Okay, so this is basically the documentation, but like it describes what is the purpose of this section, data marketplace. Okay, so also then you have the data warehouse. Okay, which is present on your Snowflake currently. Then you have the worksheets. Okay, and here it shows the history. And then you have preview app. Using preview app, like if you click on preview app, you can sign in using your credentials into Snowflake. Okay, so this works basically as an application. Okay, and then you have help here. Okay, so if you click on help, and if you go to the download section. Okay, so here you have to click on I'm using this CLI client, SnowSQL. Okay, to download this CLI client, you have to click on Snowflake repository. And if I click on Bootstrap 1.2, so I'm using Windows, so I'll click on Windows, and you can download the latest version 1.2.9. Okay, so once you download this .msi file, and you have to install it. Okay, so I have installed it on my system. Okay, so for that, what I'll do is I'll open the command prompt, and I'm running this command prompt as an administrator. Okay, so once you double click that downloaded file, just follow the instructions whatever that I mentioned, and the file will be installed, or the Snowflake will be installed like CLI client. So to start it, to check whether it has been installed, what I'll do is I'll type snowsql -v. Okay, so there's a spelling mistake here, snowsql -v. Okay, so it says 1.2.14. Okay, so before snowsql -v, once you have downloaded and installed that file, you have to type snowsql, and you have to just hit enter. Okay, so here it will get installed. Okay, so let me just clear the terminal. Okay, so the first step that we are going to discuss here is we have to log in into snowsql. So for that, I have to type snowsql -account. Okay, so the account here means the this part. And while installing, guys, I selected the cloud platform as AWS. Okay, so that's why it is showing here .aws .snowflake computing. Okay, so anything or the part before this .snowflake, it's your account. Okay, so basically this information. Okay, so let me just copy this, and let me just paste it here. Okay, so JS02084, this thing is your account, and the username that you entered while signing up. Okay, so you have to type this command to connect to Snowflake. Okay, and now it will ask for password that you entered while signing up. So let me just type the password. Okay. Okay, so guys, as you can see here, you have now logged in into Snowflake. This is the user. Compute underscore warehouse is the current data warehouse. Database, currently you do not have any database, and there is no schema for this database. Okay, So this means you are now connected to Snowflake. Okay. And just for demo purpose, guys, I have downloaded, like, in my C drive, I've created this folder temp, and here I've created a few, like, I've downloaded a few sample data, which is basically a CSV files of employees. Okay. So we'll be using this example in this demo part. Okay. So basically this was a zip file that I downloaded and I extracted it here, 5 employees.csv files. Okay. So I'll be using them in this example. Okay. So the next step here is, creating the Snowflake objects. So basically we have to create a database, a table, and a virtual warehouse. Okay. So for that, guys, the commands that we'll be using here, I've already, used these commands, or I've already written these commands in a text file. Okay. So I'll be just using these commands, to create a database first. Okay. So I'll just copy it and I'll just paste it here. Okay. You can name your database whatever you want. Okay. So I've just used this word sf_tuts. Okay. So if I type this command, like, basically this is a SQL query, create or replace database sf_tuts. Okay. So here it says database sf_tuts successfully created. Okay. So now we have to create a table as well. Okay. Sorry. Before that, we have to select the current database and the current schema for it. Okay. So let me just select the current database and current schema. Okay. So here it says current database is sf_tuts and the current schema is the public schema. Okay. So here, as you can see, since we have selected the database, here it shows before it was, no database. So here it says the name of the database that we have just created. Okay. Similarly, we have to create a table related to employees. Okay. So for that, I've already written a query and I'll just, copy this and execute it here, the query, to create a table. Okay. So create or replace table, EMP basic, and this table has fields such as first name, last name, email, street, address, city, and starting date, or the employment starting date. Okay. Once I type this query and I hit enter, it says table employee basic successfully created. Okay. And then what we have to do is, similarly, we have to create a virtual warehouse. Okay. So the command for that is create warehouse and, the warehouse name with the fields related to warehouse. Okay. So let me just copy it here and let me just paste it here. Okay. So before hitting enter, let me explain you what are we trying to achieve here. So create or replace warehouse, the warehouse name with warehouse size, which is X small. And then we have auto suspend 180, auto resume true, and initially suspended true. Okay. So the warehouse is not initially started, but it is set to auto resume. Okay. So it will automatically start running when you execute your first SQL command that requires compute resources. Also, now you must note that the warehouse is now currently in use for this session. Okay. So now we have to just select, once we hit enter, the warehouse will be created and we have to select current warehouse. Okay. Oh, there seems to be syntax error. Okay. So the current warehouse has been selected, sf_tuts_warehouse. Okay. So now you can see here the warehouse has been selected. This is the database and this is the schema. Okay. So with this, we have completed this step. So the next stage, or the next step here, is staging of the data files. So Snowflake supports loading data from files that have been staged in either an internal, that is the Snowflake stage, or external, in this case like Amazon S3 stage. Okay, so loading from an external stage is convenient if you already stored data files in this cloud storage services. Okay, so as of now we are not using any cloud service like Amazon S3. We are using the local storage. Okay, so before starting this demo, I showed you the CSV files that we had stored in the C drive in the temp folder. So now we'll be using these files. Okay, for that we are using the put command, and the command for that is this command: put file, the location of the temp files. Okay, so this basically it selects all the files with this prefix employees 0. Okay, okay, so let me just copy this command and I'll just paste it here. Okay, so before hitting enter, let me explain you what this command means. Okay, so file specifies the full directory path and the names of the files on your local machine to stage. Okay, so while specifying the file name, we can use the wildcards. Okay, and this component, this @ sfstruts dot public dot emp basic, this indicates to use the stage for the specified table, and in this case we have this table called employee basic. Okay, and put command here compresses the files by default using the gzip as indicated in the target compression. So let me just first hit enter here. Okay, so as you can see here, we have successfully staged all the data files that we had in the C drive temp folder. Okay, 5 rows, and here we have the 5 CSV files. Okay, and the source compression is none, and the target compression is gzip. Okay, status uploaded. Okay, so we have successfully completed this step of staging the data files. Okay, so now let's move on to the next step here, in which we will copy the data into the target table. Okay, so for this we will use the command copy into table, and this command will load your staged data into the target table. So this command requires an active running warehouse, which we created in the first step. Okay, while we were creating the Snowflake objects, there we created a warehouse as well. Okay, so the command for this step is copy into table. So let me just copy it from here, and okay, so copy into the table from the location employee basic file format, type CSV, and field optionally enclosed by double quotes, and the pattern here is the files are basically compressed into CSV files are compressed into gzip format. Okay, and if there is an error into copying the files, you can skip the file. So that's what we have mentioned here. Okay, so the copy command also provides an option for validating files before you load them. Okay, so once you write this command and you hit enter, so once you hit the enter button, you can see something like this. Okay, so now the files have now been loaded into the target table. Okay, so now we this table that we created, employee basic, we have data into this table. Okay, so for that we can use the query select star from employee basic. Okay, so as you can see here, from the CSV files we have this data. Okay, so basically 25 rows produced. So 25 rows, these are the data from 5 CSV files, like each file had 5 rows. Okay, so 5 files, 25 rows. Okay, so this was the data from CSV files. We got it into our table, which is employee basic. Okay, So now you can you can also insert additional data into this table. Okay, so let me just insert two tables, or sorry, let me just insert two rows in this table. Okay, so insert into employee basic values, and these are the values I'm inserting. Okay, first name, last name, email, street address, city, and the start date. Okay, so for these two people, and once I hit enter, it says two rows produced. Let me again type this query, select star from employee basic. Now it has 27 rows. Okay, so we have added two more rows. Okay, so similarly we can also query rows based on email address. Okay, so say for example, select email from emp basic, where email like yeah, say for example, I have to select people where the email address ends with uk. Okay, so as you can see here, it ends with .uk and .uk. Okay, so I have to select only these emails, or you can say also you have this au basically stands for Australia, so we can use something like au as well. So let me type percentage dot au. Okay, so this will select respective rows where this matches with email matches with .au. Okay, oh, it says I have made a spelling mistake. I have wrongly typed select. Okay, so once I hit enter, okay, so here I have two rows with this mail. Okay, and you can also query this table based on whatever you want, like you can even select a city, or a starting date, or anything. Okay, so this is how you query the data as per your requirements. Okay, and similarly, once you have the data in your tables, you can perform the main, basically the whole purpose of Snowflake is uh, you can provide, so basically you can perform all the ETL operations on this data now once you have it in your tables. Okay, so this was the whole idea behind Snowflake. Okay, so let me just quickly summarize whatever we have covered here. First, what we did is we connected to Snowflake, like we logged in, and then we stage the files containing the data to be loaded. Okay, the files can be staged internally or in an external location. Internal location is the local file system that is present on your system, and the external file location is the cloud. Basically, like in our case, it was like it would have been, if it would have been possible, we would have used Amazon S3. Okay, next what we did is we copied the data from the staged files into a target table. Okay, so and a prerequisite for this step is running an active warehouse. So these were the steps that we performed, and then you can query the data, you can perform analytics, you can use ETL operations on this data, and this way you can discover insights out of this data, whatever data that you have. Okay, so basically this was the whole introduction to Snowflake. Okay, I hope you guys have understood whatever we have covered here. Okay, yeah, so with this we have come to the end of this tutorial, like Snowflake tutorial, and I've enjoyed a lot covering all the topics in this session. Okay, so if you guys have any doubts or any queries related to this session or the demo part as well, then you can write them in the comments box below, and my team is here to help you with all your doubts. Okay, so with this, I conclude this session. Thank you so much for being with us, and happy learning.